Hi friends, welcome to our channel. Let's have a look at today's daily challenge problem. Check if a number is a sum of powers of 3. So this problem is rather straightforward actually, as long as you realize what's it saying. So here we are given an integer n. We want to return true if it's possible to represent n as the sum of distinct powers of 3. Otherwise, we return false. So if you look at 12, so you can write 3 plus 9. So we should return true. Similarly for 91. So for n equals 21, it's false. So this n is in between say 1 and 10 to the power 7. So if you are familiar with the binary representations or decimal representations, representations we use daily, right? Binary representations we use also very often. So for example, in general, if you have p based representation of a number, right? So here actually it's nothing but we want to check if in the base 3 representation of this n, if all the coefficients are either 0 or 1, in other words, there's no 2. That's all what it means for this problem. So 12 and 19 works, and we return we return true. But for 21, so if you look at its base 3 representation, so you divide this. See, let's first get this quotient and r. So let's dev mode 21 and base 3, right? So you get the quotient is 7 and the remainder is 0. So now if you do the same for 7 and 3, right? Dev mode 7 and 3. So you get 2 and 1, right? So then you do dev mode 2 and 3. You're going to get 0 and 2. So the remainders, actually they are forming a set that is 0, 1, 2. Because we have 2, right? So this cannot be true. In other words, we cannot write 21 as a distinct power of 3. So with that said, I guess writing the code is rather straightforward. So let me quickly finish it. So we can do remainders, right? So we can use a set. So then what we do is for n is greater than 0. So we consider dev mode of n with respect to 3. So we update this n by this. We call it the quotient n, and the remainder will be r, right? And then what we want to do is we want remainders and r, right? So we just need to return 2 is 2 not in remainders. That's what we want, right? Now let's run it. So it passes all the cases. So actually this code can be improved slightly. So this way of writing is in 100% correspondence with here the walkthrough. But if you want to do this differently, you can do like this. Copy this one. So we don't want this r to be 2. So if r equals 2, so we can do early stopping, return false. Otherwise, we can return true. So it's the same thing. Now let's check. Submit. Yeah, let's see if let me first change this one to be version v1. Now let's do a check. Yeah, it passes all the cases. I guess that's basically about it for this problem. I guess this problem tells us that interpreting the problem in a reasonable or convenient way is also very important for solving problems. With that said, I guess that's it for the current video. Thank you.